Good morning. First of all, I'm Mahdi Kodar, Cycle 33 at Polytechnic di Torino. The topic of my research is about landmine detection using hyperspectral imaging. This project is supervised by Professor Tiziano Benke and Professor Massimo Zucchetti. So, third world countries have long suffered from landmine problems that threaten cities. Unfortunately, existing technique in landmine detection like metal detector, training dog, mechanical clearance are generally slow and dangerous. Knowing that new technology may provide effective alternatives, we propose to use hyperspectral images. We developed a procedure based on pixel similarity in order to detect rare pixels present in the scene. The method can be combined with existing method in order to improve their performance. This method. So, which classification techniques are suitable for landmine detection? Can we decrease the complexity of these techniques? How to decrease the dimensionality reduction of a spectral image at the pixel level? So, a comparison study was made between 6 existing techniques while trying to detect 6 types of landmine. The comparative study is in terms of probability of detection, false positive rate, and computational time. The detection technique are represented by spectral angle mapper, orthogonal space projection, adaptive coherence estimator, constant energy minimization, spectral information divergence, and matched filter. So, we test this classification algorithm on different images taken from the average airborne visible infrared imaging spectrometer. The spectrum of 6 types of landmine plated in this image in different percentage using this equation. PS equal alpha t plus 1 minus alpha b, where PS is a simulated spectrum, T is a target spectrum, P is a background material spectrum, and alpha is a field fraction. So, these are the 6 types of landmines. At the computational time, as you see, AC has the highest computational time, where OSP SID has the lowest one. Concerning the false positive rate, as we see, ACE has 0 false positive rate, where other method has some false positive rate. So, ACE has good algorithm for landmine detection, but it has high computational time. From this problem, in order to foster the detection of ACE method, we propose to detect landmine using pixel intensity method. The idea is to apply pixel intensity method in order to detect the rare pixel present in the scene and then apply ACE to this rare pixel. This will decrease the complexity of ACE method. So, a real experiment consists in an area containing soil, grass, wood, water, and multiple materials. To be more realistic, as you see in the image below, a CNC router is used to handle this spectrometer to scan the whole area. This spectrometer is an Hamamatsu spectrometer with the spectral range between 350 and 700 nanometer with a spectral resolution of 3 nanometer. In the proposed scene, 2 types of landmine are used, metal landmine and plastic landmine. Also, a TNT explosive with nitric mixture is also used in this scene. These are the distributed scenario of landmine in the image. As a result, a comparative study between ACE and PI plus ACE with pixel reduction rate equal 47.5%, as you see. Concerning the average time, we can reduce the average time of ACE when using the pixel intensity. Concerning the false positive rate, we can reduce the false positive rate using for metal landmine to 0. For plastic landmine also, we can reduce the false positive rate to 0. And for the powder, we can stay with the same false positive rate, which is 0. So, as conclusion, we propose a pixel similarity method to improve landmine detection in hyperspectral imaging. ACE has better performance compared to other existing methods, but it has the highest computation time. Using the pixel similarity method with ACE, we can reduce both the execution time of ACE, reduce false alarm rate with 100% detection rate. The experiment was done using the visible to near infrared range to detect only surface landmine, where, as a future work, new experiment will be done on thermal infrared imaging in order to evaluate the ability to detect fully buried landmine. And thank you very much.